Okay, this is the class notes for a closer look at homogeneous mixtures. Closer look at homogeneous mixtures. Closer look at homogeneous mixtures. Okay, so there's two types of mixtures. We've talked about them before, heterogeneous and homogeneous. Two types of mixtures. Heterogeneous and homogeneous. Heterogeneous and homogeneous. Okay. And I'm going to try to make the light a little bit better. So be okay, so hopefully that's a little bit more legible. Okay, so heterogeneous and homogeneous. Now we talked about both of these. Heterogeneous means not uniform. Not uniform. So you can see the pieces of the mixture. It will look like a mixture. Okay. You can see the parts. Looks like a mixture. Homogeneous, on the other hand, is uniform. And now we're going to go into a lot more detail on homogeneous. So I'm going to bring that one down here and go into the details for that one. So homogeneous or homogeneous is uniform throughout. Uniform throughout. This means that the particles are evenly distributed and it looks the same all the way throughout the mixture, okay? So particles evenly distributed. Looks the same. It doesn't look like a mixture. It looks like it's pure, okay? Okay, they can be any physical state. So these mixtures can be any physical state. These mixtures can be any physical state. So we're going to do a few examples. And we've seen these before, but we're going to talk about them in a slightly different way. So, for example, solid could be stainless steel. Okay. Stainless steel, which is, I'm going to do an equals there, mixture of iron, carbon, and chromium. Iron, carbon, and chromium. They're all mixed together, but none of them are bonded to each other. And that's the difference between a mixture and a compound. Okay, a homogeneous mixture, they're together physically, but they're not forming bonds with each other, which means the ratio of their pieces can change. You can have a higher percentage of iron or a higher percentage of chromium, and it could still be stainless steel. Okay. All right, a liquid example would be gasoline. Okay, gasoline is a good liquid example. It is made of okay, so back to gasoline. Gasoline is made of hydrocarbons. Of various lengths. So you might not know what a hydrocarbon is at this point, okay? But hydrocarbon kind of tells you what it is in its name. It's a molecule made out of carbon and hydrogen. So these are chains of carbon and hydrogen. So could be 6 carbons long, 8 carbons long, 10 carbons long, and you mix those together, you get gasoline. It depends on how long they are, but various lengths make up gasoline, okay? And then a gas example would be air, okay? Air is a homogeneous mixture if you're in a small enough sample. So if you took a little sample of air from a room, for example, it is a mixture of mostly nitrogen and oxygen. Okay. The third most common component to air is actually argon. We also have water in our air, CO2, but all of those things are much smaller. These are the 2 major pieces of air. Okay, one more piece here. Another name for homogeneous mixture is a solution. Another name for homogeneous mixture is solution. The words are the same, okay? Homogeneous mixture equals solution, solution equals homogeneous mixture. They're the same thing. Please, please, please get that into your brains, okay? Solution means homogeneous mixture. Stainless steel is a solution. Air is a solution. Gasoline is a solution. Now, in previous science classes, you might have thought a solution just meant when you've dissolved something in water, you're making a solution, which you are. If you dissolve sugar in water or salt in water, those are solutions. But air is a solution of nitrogen and oxygen. Gasoline is a solution of hydrocarbons. Stainless steel is a solution of iron, carbon, and chromium. Because they're all homogeneous mixtures, they are all solutions. So we have to adapt our definition of the word solution to include anything that's a homogeneous mixture. Okay, more information about solutions up here. More info about solutions is what that says. More info about solutions. Solutions are made of a solvent and 1 or more solutes, which we're going to explain in a second. Solutions are made of a solvent and 1 or more solutes. Okay, solvent and 1 or more solutes. Now we're going to define those things under here. So a solvent. Solvent is our first word. It is something that dissolves a solute. So it's not the thing dissolving, it's the thing doing the dissolving, okay? So typically when we're thinking about solutions, that would be water. You dissolve salt into water. You dissolve sugar into water. So the water is the solvent, okay? So typically water, I'm going to put that in parentheses, typically water but it can be any physical state. But it can be any physical state and is present in the largest quantity. Okay, largest quantity. So that means that if you're mixing two things together, the one that's there in the higher amount is the solvent. The one that's there in the lower amount is going to be the opposite, the solute, and that's what we're going to define next. So solute. Solute. Something that dissolves in a solvent. Something that dissolves into a solvent. Something that dissolves into a solvent. It is present in smaller quantity. Smaller quantity. So we usually dissolve salt into water or we dissolve sugar into water. Those would be solutes. But if we're not talking about water, if we're talking about steel, okay, the smaller pieces of steel, carbon, chromium, if it's not stainless steel, it might have titanium in it. Those pieces are going to be the solutes. Iron is the key component of steel. It's the largest quantity, so iron would be the solvent. Okay, so we're going to just digest all three of the examples from over here and talk about the solvent and the solute in each of those. So I'm going to erase the board on this side so we can have more space. Well, okay, so similar place in your formatting here. Whatever you were using for this part, we're going to keep it at that indentation. So in our examples, we'll start with stainless steel. Stainless steel, the solvent is iron. Solvent is iron. The solutes would be carbon and chromium. Carbon and chromium, if you want to write them out, you can, but carbon and chromium. In gasoline, we have a solvent of isopentane. So that's one of those hydrocarbons that we were talking about, isopentane, and it's the biggest part of gasoline. The solutes, I'm going to list them down here. Solutes are going to be, change those to equal signs here to stay consistent. Okay, solutes are going to be propane, hexane, octane, etc. Okay, I don't know if you guys have ever heard of high octane fuels. High octane fuels burn at a higher temperature. So octane is one of the pieces to gasoline. High octane fuels can become, to a point, when you get high enough octane, it becomes like jet fuel. Okay, so we're getting to higher propulsion there. Okay, and then for air, the last example that we talked about, the solvent of air is nitrogen. Okay, almost 80% of our air is nitrogen. Solutes would then be oxygen, water, CO2, argon, and everything else that's in air, okay? Okay, now back to our major bullet type here, okay? Solutions can be dilute, saturated, or supersaturated. Dilute, saturated, or supersaturated. Now we're going to define each of these. And for this last one, we're going to give you a procedure for how to make a supersaturated solution so that you can answer that question later on in lab. Okay? So, dilute. You probably already know what dilute means, because if I said, I want you to dilute this Gatorade, what would you do? Well, hopefully you're thinking to yourself, you would add more water to it, water it down. So dilute means there's some solute dissolved, but there's room for much more. Some solute dissolved, but room for much more. Okay, so you can add a lot more sugar to that water or a lot more salt to that water because there's still room for more. Okay. All right, that's dilute. Now we're going to go into saturated. Saturated. All right. This word means the solution has as much solute as possible. Solution has as much solute as possible dissolved. Solution has as much solute as possible dissolved. This amount depends on type of solute and temperature. This amount depends on type of solute and temperature. So hopefully you all have experienced, and if you haven't, it's okay, but if you have ever tried to put sugar into an unsweetened iced tea and you try to dissolve it, it's pretty hard because iced tea is very cold. But if you put sugar into hot tea, it dissolves without any effort. Okay, so when you raise the temperature, usually things get more soluble, and it also, again, depends on what you're dissolving. Now, if you add more stuff to a saturated solution, so say I put as much sugar as possible into the tea, it won't take any more. It's saturated, it's full, okay? When you add more sugar, those crystals go to the bottom. They just kind of add to the bottom of the cup, okay? That's called oversaturated. And that is no longer a homogeneous solution. It's heterogeneous because you have sugar on the bottom that you can see, a different part to that mixture, okay? But the last piece I'm going to talk about is supersaturated, which is still a solution. It's still homogeneous, okay? Supersaturated. Okay, we're going to define it and then we'll talk about how you make it. It's a special solution. Special solution in which more solute is dissolved than should be at that temperature. In which more solute is dissolved than should be at that temperature. Special solution in which more solute is dissolved than should be at that temperature. And so you may be like, well, how does that work? If you can't get more than that at that temperature, how do you get more dissolved? Well, I'll tell you, okay? Here's what we're going to do. These are the steps to make it. To make this, 1, you boil the solvent. Boil the solvent. Now, when you boil the solvent, the molecules spread apart, and that makes more room for more solute to dissolve, okay? So boil the solution. Oh, sorry, the solvent. This spreads the molecules apart. This spreads the molecules apart. Step 2, dissolve as much solute as possible. Dissolve as much solute as possible while it's boiling. You have to keep it boiling so those molecules stay far apart. Then you dissolve as much solute as possible in that boiling solvent. And then 3, cool the solution. Cool the solution. That solute will actually stay dissolved as you cool the solution, as long as you cool it carefully. If you cool it too fast, it'll fall out of solution. And if you disturb it, it will fall out of solution, okay? So that's one last thing that I want to talk about, which is really cool with supersaturated solutions. Once made, the solute is easily disturbed, okay? The solute is easily disturbed solute is easily disturbed by adding 1 more crystal of solute. By adding 1 more crystal of solute. When you do that, so if I have as much salt water, supersaturated saltwater solution, I drop 1 crystal of salt into the top of that solution, and the entire thing will crystallize. All of the solute will come out of solution, okay? So, by adding 1 crystal of solute, starts a chain reaction to crystallize all of the solute. Starts a chain reaction to crystallize all of the solute. I know I kind of went into this half, but I ran out of space. So it's really cool. We're going to watch a video of that supersaturated solution. You just drop a crystal on the top of it, and all of the salt or the sugar or whatever's dissolved will crystallize throughout the whole container. And it's really, really cool to see. Okay. All right, that's the end of these notes. And now you're going to be ready for our next activities. We'll see you in class. Thanks for watching.